Hi, this is David Sellers. This was part 3 of the presentation I did at the Emerging Technology Summit. This is the last part. I broke it up into 3 parts just to fit it on the YouTube site. Now, all that being said, you buy a really great filter and put it in a mediocre frame, you're sort of lost. This system here had 95% efficiency filters, pretty high efficiency, in what are fairly vanilla frames. And you see these frames a lot. They're riveted, 16 gauge. There's no stiffeners between the sections. There's not caulk. There's foam gaskets. There's no knife edge seals. There's nothing really forcefully shoving the filters against the gaskets. And so, if you were to measure it in the field, which is hard, but I suspect that you're getting less than MERV 14 out of the assembly. The other thing to think about that we don't think about until a filter bank collapses on us is that the structural loads can be significant. Like, for instance, in this filter bank at the dirty pressure drop, there's 30 pounds of force acting on each of those filters, and if you have a big filter bank, that adds up. And this, these sheet metal frames are just like a little wobbly mesh of stuff if they aren't reinforced. They're supposed to be reinforced, but people don't pay attention to that. Another problem related to semi-rigid filter banks. This is a filter bank where we actually installed the lower pressure drop, higher dust holding capacity filters, and we were basically just experimenting. We had a particle counter, so we said, well, gosh, let's see what the particle counts are upstream and downstream. And measuring particle counts in the field is a totally different scenario from the lab. For one thing, you're as big a source of contamination as anything. We were just looking for patterns and trends. And what we noticed, what was really clear from our data, was that one system had significantly higher particle counts downstream of the filters than the others, to the point where the vendor, and there are reputable vendors out there, the vendor was really concerned that they thought, man, we got a bunch of bad media or something. They actually paid to pull a couple filters and send them to an independent testing lab that we picked and have them tested. And we were expecting to get a report back that said the media is bad. We got a report back that said these are really good filters. You ought to buy more of them. And we got to looking and we realized these filters were fairly close coupled with the economizer dampers. Like, I'm standing there measuring airflow and the economizer might have been 2 feet behind me. Well, in certain operating modes, you get turbulence in this plenum and it would cause the filter bank to shake. And we're pretty sure that shaking was either shaking particles loose from the filters or just shaking particles loose from the assembly, or opening up cracks, any number of things or all of them. But that was affecting our filtration efficiency. And we've actually reinforced the framing system, but I haven't had a chance to go back and see what the impact of that's been. And it would be fairly qualitative, but it would be interesting. We just haven't gotten around to it. But there's another example of a detail that matters. In the samples I sent down, there's actually there's a Camfar Type 8 frame, which is very typical. We see these a lot. There's nothing wrong with these, and for a pre-filter, it's probably just dandy. But if you apply this with a high efficiency filter and don't do it right, or even if you do it right, you may be compromising the filter. And one of the biggest compromises is that rigidity thing. If you look at the details on the thing that comes with the filter, the pieces of paper you see blowing around a construction site, the installation instructions, that says basically every other row you ought to have a reinforcing stiffener. That would help a lot with a number of problems, including the structural loads and the vibration problem we just talked about. Bottom line is, this is about $66, $67 a hole, like for a 24 by 24 assembly. Now, if you contrast with the higher end sort of thing, this is from a company called Total Filtration Manufacturing, the OptiFrame. It's extruded aluminum, like all sorts of gasketing between the modules, knife edge seals for the filters, a lot of things targeted at addressing the issues that come up with the less expensive filters, but it comes at a cost, of course. It's double the cost, but if you're trying to do high efficiency filtration, maybe this is something you need to think about, otherwise you're just fooling yourself. And you'll see this is bent up here. Well, that's because my sample had an encounter with a forklift being shipped up. Actually, we were getting better shipping cases built because our boxes kept getting destroyed like this. And at first, the vendor was horrified, don't show that to people. And I said, well, look at that, it got pronged by a forklift, and basically it bent the crap out of the frame, which is really, like, when you look at this, you aren't going to bend this unless you're like Popeye or something. But it bent that. The rest of the frame is just fine. That's actually a testament to the integrity of the system. And I'm pretty sure if I'd run the forklift through the other frame, it wouldn't have come out as good. And again, not trying to endorse or anything, any particular product, but I'm just saying there's something to be said for some of the features of a higher quality frame, and that's part of your filtration system. Now, trying to assess the reality of all this, you got in the field and measure a filter with the frame and with all the field conditions. That's different than the lab test that ASHRAE does, which is just on the filter itself. There's actually now an ASHRAE guideline for testing filters in the field, and at least one of the vendors, I think Camfil Far, offers this as a service. We're actually, because we're curious about it, looking at gearing up and buying the stuff we need to do it, because we got a bunch of field trials running. And the field trials I'm logging data on pressure drops. I got the energy thing nailed. I don't know much about the installed efficiency. Here's one of the field trials. This is the one I have the most data on. It's been doing it with Jess Shapiro up at Kaiser Permanente in Portland. And they had two identical systems, like literally the same load profiles. It was like a dream in terms of a field trial. And so we could run one the way they were running it and put the better solution, or what we thought was the better solution, in the other system, and just see what Mother Nature had to say about the whole thing. And we've been logging 5-minute data now for we're just a little bit over 2 years. And basically we're comparing a soft pocket bag filter with a roll filter type pre-filter with one of the rigid pocket bag filters without the pre-filter, with the little spacers in it and everything. And it was interesting when we got into it far enough to think we had enough data to do trends and projected trends. The trends basically said that the alternative solution, the thing we thought was going to be better, that if it did what the model said it would do and what the trends said it would do, at the end of 2 years, which is when they arbitrarily changed filters in the old approach, its pressure drop would be basically about the clean pressure drop of the alternative approach. And we're at, like I said, we're a little past 2 years. I've got a bunch of data. I haven't had a chance to resolve it because everybody's doing this pro bono sort of between things. But there's a picture of the gauges. On the left, we're at a little under 0.2 inches, which is what that line projected to after 2 years for the alternative system. The system that is conventional, the way they've been doing it for the life of the building, we were up at 0.4 of an inch. So it looks like our projections are panning out. And in fact, we're planning on running the alternative. We're just going to keep running it. We think it'll last 3 or 4 years. But we were worried that we were going to grow biological stuff, or maybe there's something growing in the filters. So we actually pulled one to have it tested, and there wasn't. But one of the things we found out is that filter had picked up 277 grams of dust. We actually had weighed not all of them, but weighed representative filters before we installed them. What's interesting about that number to me is 277 grams of dust is more than the conventional filter is rated to pick up. Now, granted, just running the pre-filters, so that probably helps that a little bit, but I just got that number. So we went and bought a scale that could weigh filters and resolve, like 0.2 of an ounce. So I'm actually going to weigh a bunch more filters and see how much dust the different filters have picked up. But it sort of makes you wonder, if this one's picked up 277 grams, and that's like as much or more than the conventional approach is rated, why isn't the pressure drop in the conventional filter higher? What could be the pre-filters, but it also could be related to something else we noticed, which I sort of had always figured was going on, but here's a picture of it. This is some of the earlier data I collected, and I noticed for the conventional approach, the pressure drop was dropping with flow just like you'd expect, but then all of a sudden it would go back up. And I was thinking I had bad data, and I was like, oh man, I need to get over there and figure out what's wrong. And then I realized, I know what's going on. The conventional filters, they're flexible bags, and when the flow drops below a certain level, they sort of collapse. When they collapse, the pressure drop goes up. When the flow picks up to inflate them, the pressure drop drops. In contrast with the extended surface area filters, which are rigid and have the little spacers, they never collapse. And the other thing we suspect is going on, like when that filter collapses, we think it probably breaks the dust cake, and so it probably sheds some of the particles it collected. And we can't prove that, although we actually are going to try and get a particle counter downstream of both beds and cycle the fans a couple times and see if we see particle spikes. We don't really know, and this is a field situation, and I'm not trying to say this is pure science. I'm just saying here's what we're seeing, and it's kind of interesting. Now, you've got to practice due diligence, which is why we pulled those filters. This is some research that was published in ASHRAE from a study in Denmark, and this author had identified that the perceived air quality by the people in some office buildings was less with a longer filter life, which I'm pushing for longer filter lives, and he's saying, not so sure, because people were perceiving the indoor air quality wasn't as good. It's really interesting. Actually, it isn't like dangerous. It's just odor and their perception of the air being clean. And it's related, they think, to stuff that's trapped in the filters when a system's scheduled off and there's not air flowing past it, and so it doesn't have a chance to react, and basically you build up off-gassing, and then when you start the fan, you blow that down the system. And so the schedules actually made this problem worse. Active carbons seem to mitigate it, and also cartridge filters like that rigid V-bank filter seem to not be as prone to this problem as this bag filter was. And this is a study in Denmark. We haven't seen this, but this is one of the reasons we pulled one of the filters and had it tested just to see if there was anything growing on it or anything like that. So my point is, we're talking about pushing the envelope here, so you need to think about all the angles and practice due diligence. So here's some resources. I'll just, I'm not going to read them all off to you. The one thing I will point out is I have a blog. It's a technical blog, but I'm actually publishing the results or posting the results of our field trial there every once in a while. So if you're curious about that, you might want to watch the blog, and I'm sure I'll stick the weight of the filter thing up once I know that data. If you have additional questions, here's all my contact information, and Paul Delaney has my samples someplace. I'm sure he can fill you in on that. I appreciate your attendance and your patience with me not being there and being there virtually. So thank you very much for your time, and I'll sign off.